If you look at the virtual memory management windows, if you look at the 32-bit Windows, split the user mode address space or splits the 32-bit address space into portion that's going to be used by the OS and a portion that's going to be used by app processes, user mode processes that run like Notepad and so on. And that split by default is right in half. 2 gigabytes of that 4 gigabytes outer space are usable by the application. So 2 gigabytes are going to be used by the system, by the OS drivers, and here's a pictures down here that shows that default split. And so what you got are different user mode address spaces. Whenever a thread from a different process run Windows memory manages swap whatever in map into this 2 gigabytes with the address space of the process. Well, that is scheduling like a notepad, so it supports all the features like you expect out of a modern memory management subsystem. And all the features you expect and more actually supports 32-bit or 64-bit. So there is a 64-bit version of Windows. It supports copy on write so that application can share memory, and that when they modify it is become private to them. So the modification is support share memory, so application can share data easily, and it supports memory map files which are used for image execution. For example, like running a program is mapped into the address space of the executable. So that's the way when Windows manage the virtual memory of the processes running on a machine. So let's talk about how they manage the physical memory. So physical memory management means that you get a fixed amount of physical memory. What processes do you let use that physical memory? Well, your goal is to give them physical memory to the processes that need it the most, the ones that are the most memory hungry and actively using their memory processes. They aren't using physical memory or that idle. You want to take paid memory away from those guys and give it to the guy that need it. What you do with the pages, you're taking away the data that was stored and there is send it, and it will send it off to the paging file and then bring it back when you need it, when the application wants to access it again. So one of the policies that an operator memory manager designer has to decide on is when a process needs another piece of memory, another page of memory, where that page of memory should come from, where that physical piece of memory should come from, where who should steal it from. All of our physical memories in use Windows has what's called a per process working set, where a working set is the list of the physical memory assigned to that process, and the page replacement algorithm, the memory manager used to decide who to steal a piece of physical memory from give it to the process needing another page is called local page replacement. And so here's a picture of a local page replacement. This process here wants another page of physical memory, and what the memory manager does when it decides this process has gotten big enough and there's no more free memory on the system, is organize the memory that process is access from the most recent to least recent, and it will take the least recently access the one that the process of memory that process is accessed most recently in the past, figuring it is not going to need it again in the near future, and steals that page away from that process, and it will giving it back to it. So for whatever it wants to use new memory for now, the other processes also have their working sets on this list from they are sorted that way. In process management, well, the definition of process in Windows is a container, and that container has a few things associated with it, including an address space that holds the code and data of the program, so that is being executed in the process, so that it also has a list of resources and they are opened by the process, and the resources can include files and registry keys, and it also has at least one thread. A thread is what actually executes the code, not the process. The process has to have a thread within it to execute, so the scheduler, when it decides who's going to run, will pick a thread to run, and that thread belongs to a process. So you can think of that process is running when it's actually a thread within that process. And there is no inherent parent-child relationship between processes and their children processes. They create in Windows, and threads being the basic scheduling unit, or what the scheduler looks at the priorities of the threads to decide what to pick next to run on the CPU. Windows also has what are called user mode threads or lightweight threads, which are called fibers, and fibers are actually made without any support of the OS itself, so they are totally up in the user space, and It's where an application basically become its own scheduler.
I have a folder here called OOP. Here I can click on it, I can rename it by just right click and rename it to OS, for example. I double click, I can open it, so I can change the view by just click on the view and just change whatever I want it. And if you go for the details, they will display you the name, the data modifier, the type, and the size, so that it will be more systematic. Here I also can resize my window a little bit. I can drag it here, I can move it here. And I also can create new folder by right click and click on new folder. I'm gonna name it as OB. I also can copy the image by here by clicking on the image and then click copy and then right click and paste it, or just using Ctrl C Ctrl V, the shortcut. I can also drag the file by just drag it here. I also can delete the file by just by right click and delete the file.